Buckle up, because we're diving into a cosmic mystery that's out of this world. Cast your mind back to 2017, a time when the universe decided to throw us a curveball in the form of Oumuamua. This interstellar guest crashed the astronomical scene with a bang, catching everyone off guard. With a name like Messenger from Afar, you just know it's going to be a wild ride. Picture this: a group of intrepid Hawaiian astronomers scanning the night sky as usual, when suddenly they stumble upon something that defies all expectations. Oumuamua isn't your run-of-the-mill space rock. It's a cosmic enigma wrapped in a riddle. Its peculiar shape, its erratic behavior, it's like nothing we've ever seen before. Fast forward to today, and NASA has dropped a bombshell. Oumuamua is making a beeline back to Earth. Cue the dramatic music. It's a race against time as we scramble to uncover its true nature before it's too late. This is the stuff of science fiction, folks. Except it's all too real. Think about it. This isn't just any old space rock. Oumuamua is rewriting the rulebook on interstellar visitors. It's the cosmic equivalent of crashing a party uninvited, and scientists are buzzing with excitement. We're talking late-night brainstorming sessions, wild theories flying left and right. It's like the Super Bowl of astronomy. But here's where things get really juicy. Some folks are saying Oumuamua might not be a comet or asteroid at all. Nope, brace yourselves for this one. There's a Harvard professor who thinks it could be alien tech. I'm talking extraterrestrial spacecraft vibes, people. It's the kind of theory that makes you question everything you thought you knew about the universe. Of course, not everyone's convinced. Most experts are sticking to more grounded explanations, like fragments from cosmic collisions or exotic forms of ice. But hey, where's the fun in playing it safe? Oumuamua has sparked a firestorm of debate and speculation, and we're just getting started. So strap in, folks, because we're about to embark on the ultimate cosmic adventure. From mysterious red hues to wild spinning antics, Oumuamua is the gift that keeps on giving. Who knows what secrets this interstellar traveler holds? The universe is vast, mysterious, and full of surprises. And Oumuamua is just the tip of the cosmic iceberg. There are no blazing suns nearby to scorch their surfaces, no atmospheres to erode them away with wind and weather. In this light, Oumuamua can be seen not just as a piece of cosmic debris, but as a relic from the distant past, a bearer of untold stories from billions of years ago. Its odyssey through the dark, almost void-like stretches between stars, has possibly maintained its surface in a state very similar to when it was first hurled into the depths of space, making it a precious time capsule from the cosmos. Adding to this cosmic tale is the fact that Oumuamua's journey has been far from solitary. Our solar system, a bustling community with planets, moons, and the sun, each exerts its own gravitational influence. This complex dance of gravity affected Oumuamua as it ventured through our cosmic neighborhood. This is where the real detective work begins for astronomers. They use telescopes, radars, and mathematical models, acting as cosmic sleuths to trace Oumuamua's trajectory and velocity as it navigated through our solar system's gravitational maze. By meticulously tracking how Oumuamua's path and speed changed as it curved past the sun and darted by planets, scientists can attempt to rewind its cosmic journey, piecing together clues that may reveal its origin and the violent events that may have ejected it into the realm of the stars. Furthermore, this isn't just about tracking a single object's path. It's about unraveling the interconnected stories of celestial bodies across the universe. Each interaction Oumuamua had within our solar system adds a piece to the jigsaw puzzle of our cosmic neighborhood's dynamics and history. Understanding Oumuamua helps scientists understand more about the nature of other celestial bodies, the formation of solar systems, and even the distribution of potential life-forming materials across the universe. So, in studying Oumuamua, we are not just learning about a distant object. We are learning about the building blocks of our own world, and perhaps the seeds of life itself that travel across the cosmos, hidden in these enigmatic space travelers. The story gets more exciting as we follow Oumuamua's path. Can we solve the space puzzles it leaves behind? Catching a wild ride on star gravity. Let's now dive into a fascinating concept known as the gravity assist maneuver, which is somewhat like a cosmic slingshot effect. Picture yourself in an intergalactic game of tag. Suddenly, you whoosh close to a massive celestial body like a planet or a star, and you get a significant speed boost from its gravity, propelling you forward much faster than before. This is what happens in the vastness of space. Scientists study these gravity-driven speed boosts that an object, such as Oumuamua, experiences as it makes its way past the titanic occupants of space, like the planets and stars in our solar system. They meticulously tally these boosts, which accumulate throughout Oumuamua's celestial voyage. By doing so, they turn into cosmic sleuths, tracing back Oumuamua's interstellar odyssey in an attempt to pinpoint its origin. This task of space detective work has been taken up by numerous scientists who are on a quest to identify the star systems or individual stars that Oumuamua might have encountered during its journey across the cosmos. They speculate about clusters of young stars and even specific stars, such as HIP 3757 and HD 2922-49, that could have had close encounters with Oumuamua many eons ago. But piecing together the exact stellar neighborhood from which Oumuamua emerged is immensely challenging. Our understanding of Oumuamua's precise speed and its trajectory through the cosmic expanses is incomplete. Moreover, the galaxy is akin to a bustling cosmic freeway, with stars and planetary systems in constant motion, complicating the tracking of Oumuamua's original path. If Oumuamua experienced any propulsion from releasing material, akin to a cosmic jet, this would add another layer of complexity to deducing its precise route. As Oumuamua ventures through the space between stars, it's navigating through what is known as the interstellar medium, a sparse but expansive mixture that could be likened to an incredibly diluted cosmic broth, consisting of minuscule dust particles, gases, and swiftly moving charged particles. Despite the sheer tenuity of this space soup, over vast stretches of time, it exerts a cumulative influence on objects like Oumuamua, subtly altering their trajectories. This slow, graceful interaction with interstellar matter introduces an additional element of mystery to Oumuamua's story. When scientists attempt to reconstruct the colossal journey that Oumuamua has undertaken, they must consider these slight, persistent nudges. The task is similar to mapping out an epic road trip across an ever-changing, boundless stellar landscape. Oumuamua is a mysterious visitor from a place far beyond our family of stars, making it extraordinarily unique and fascinating. Unlike the usual objects we see in our sky, such as planets, asteroids, and comets that orbit our sun, Oumuamua doesn't belong to our solar system. It's like a stranger from a distant neighborhood in the vast cosmos, journeying through space from another star system altogether. Imagine someone from a completely different country, but even more extraordinary. This visitor comes from an entirely different corner of our Milky Way galaxy. The discovery of Oumuamua back in 2017 created a huge wave of excitement all around the world, especially among people who love stars, planets, and all things space, the astronomers, but also just regular folks who find space really cool. Before Oumuamua showed up, most of the things we found in space were from around here, from our own solar neighborhood, like asteroids from our asteroid belt or comets from the edges of our solar system. But Oumuamua, it was something special, something different. It wasn't just another piece of space rock floating around. It was our very first look at something that came from beyond, far beyond, the familiar boundaries of our solar system. Imagine how a kid feels when they catch a rare butterfly or find a unique seashell on the beach. That's how these space experts felt about Oumuamua. This wasn't just about seeing a new kind of space object. It was about getting a peek at the stuff that exists out in the vast, mysterious stretches of space that lie beyond our own solar backyard. It's like getting a message in a bottle from the vast ocean of the cosmos. This is why Oumuamua wasn't just another discovery. It was a big deal, A really big deal. Let's delve deeper into Oumuamua's journey. In the vastness of space, most celestial bodies in our solar system follow specific paths around the Sun, resembling elongated circles or ovals known as orbits. These paths are predictable and keep these bodies gravitationally tied to the Sun. However, Oumuamua doesn't conform to these rules. It follows what is known as a hyperbolic trajectory, a term that might sound complicated, but simply means it's on a one-way trip through our solar system. Unlike the repeating loops of planets and comets, Oumuamua visited our Sun once, received a significant boost in speed from the Sun's gravity, and is now on its way out of our solar system forever. This makes Oumuamua not just a wanderer, but a cosmic sprinter, racing away on a path that will take it out into the depths of space, never to return to our solar neighborhood again. This unique behavior provides scientists with a rare opportunity to study an object from a completely different part of our galaxy, offering clues about the vast mysterious universe beyond our immediate view. As Oumuamua's space visit ends, what last secrets is it sharing? The never-returning ancient space guest. The acceleration Oumuamua experienced is simply mind-blowing. Imagine this. It sped up to around 26 kilometers per second. To put that into perspective, it's as if you were able to race from one end of a city to the other in just a blink. No car, airplane, or even the fastest rockets that we've created here on Earth can match that speed. It's so incredibly fast that it's not just leaving our Sun behind in its cosmic rearview mirror. It's actually exiting the entire solar system. Now, it's hurtling towards a region of the sky we call the constellation Pegasus, and it doesn't have any plans to return. It's like a migratory bird that senses it's time to move to a warmer climate for the winter. Except, Oumuamua's departure isn't for the season. It's forever. Let's think about Oumuamua's visit as a singular once-in-a-lifetime event. Due to its astonishing velocity, the gravitational pull of the Sun, powerful as it is, cannot coax it back for a repeat performance. Imagine tossing a ball with such force that it doesn't just fall outside your yard, but it continues beyond the surrounding trees, the distant mountains, and keeps on traveling without ever stopping. That's what Oumuamua is doing, but on an interstellar scale. After it whizzed past us, all our astronomers could do was to track its journey, crunch numbers, and absorb as much knowledge from this brief encounter as possible. They have deduced that it will continue on its solitary trek across the universe, drifting through the endless sea of stars in our Milky Way. It might cross paths with other solar systems, or wander the lonely stretches between the stars, continuing its silent voyage across the cosmos for countless years to come. Oumuamua is like a giant cosmic arrow that came zooming in from the starry skies, pointing right at us. Think of it as a giant space pointer. Scientists have been very busy studying the way Oumuamua moves. They noticed it travels in a straight line, much unlike the circular paths that our own planets, like Earth and Mars, take when they go around the Sun. This straight way of moving, which the smart space folks call a hyperbolic trajectory, is a big clue. It suggests that Oumuamua didn't come from our own solar backyard. Instead, it looks like it traveled a very, very long distance, coming from a place far beyond our own star group, from a different part of the vast universe. Now, the direction Oumuamua came from is another interesting piece of the puzzle. It seems to have shot in from the area of the sky where we see the constellation called Lyra. Imagine looking up at the night sky and pointing to a group of stars. That's what Lyra is, a pattern in the stars far above us. But here's the tricky part. Even though we have a good guess about the direction it came from, figuring out exactly which star or planet Oumuamua was hanging around before it dropped by is really, really tough. That's because space is just so big, unimaginably big. And Oumuamua could have been traveling through this vast space for millions or even billions of years, which is a very long time. So while we have some clues, there's still a lot of mystery about where exactly this space visitor came from. Trying to pin down the exact origin of Oumuamua in the immense expanse of space is a massive challenge. Imagine the vastness of a beach, filled with countless grains of sand. Now think about trying to find out where just one of those tiny grains first came from, which specific rock it broke off from millions of years ago. That's a bit like the task facing astronomers when they try to figure out Oumuamua's home. The universe is incredibly large and filled with stars, planets, and other celestial bodies, all moving and changing over time. Despite the high levels of expertise and technology we have, this is still a daunting task because space is not just big, it's filled with mysteries and complexities that we are just beginning to understand. However, the direction from which Oumuamua arrived in our solar system gives scientists valuable hints. It's like having a compass that points not to the north, but to a specific area in the cosmic ocean, far beyond our own solar system's boundaries. This information, while it might seem small, is actually a big piece of the cosmic puzzle. It adds to our understanding of the universe's structure and how objects move through space, offering a glimpse into the regions beyond our own solar neighborhood, which is our immediate cosmic surroundings. As for whether Oumuamua will come back to visit Earth, the answer is pretty much no. Imagine a spaceship flying past a planet, moving so fast that it doesn't get caught in the planet's gravitational pull, but instead keeps zipping straight ahead on its journey. That's what Oumuamua is doing. Its path through our solar system was a straight line, not the kind of loop or orbit that would bring it back around to us. It's like a cosmic traveler that stopped by for a quick visit and is now continuing on its journey, never to return within our lifetimes, or even the lifetimes of the next several generations. This is a unique event, a rare and fleeting moment where we got to witness a visitor from the depths of space pass through our own celestial neighborhood. But just because Oumuamua is a one-off visitor and not coming back doesn't take away from its importance. In fact, you could think of Oumuamua as a sort of cosmic messenger or ambassador. It's carrying with it secrets from a distant part of our galaxy, cruising by us by chance. Even though it doesn't send messages or signals, the information we can gather by observing its speed, trajectory, and physical properties is invaluable. By studying these aspects, scientists can uncover clues about the conditions and forces at play in other parts of the Milky Way. Has Oumuamua unveiled the true vastness and mystery of our universe? Or is it just the beginning of an even greater cosmic story? Share your thoughts below, and don't forget to hit the like button and subscribe for more mind-bending space mysteries.